So once again, I want to welcome everyone to tonight's webinar on National Weather Service Aviation Services. I'm Joe Deli Carpini, the Science and Operations Officer. With me tonight is Bryce Williams, one of our meteorologists and our social media program leader. And I want to introduce a new member of our team here. This is Scott Reynolds, who is the meteorologist in charge of the Boston Center Weather Service Unit, or CWSU. So Scott, why don't you just briefly introduce yourself, since this is the first webinar you've attended with us.
Okay, thanks, Joe. And I'm hardly new to the Weather Service. I've been the meteorologist in charge of Boston Center Weather for about 15 years now. And while we are part of the Weather Service, we also work very closely with the FAA. We'll get into a few of the details about that as we go on. But the CWSUs and the weather forecast offices have a very unique partnership in terms of aviation weather, and we'll get into that a little bit more as the night goes on. I've been in the Weather Service for over 30 years now. Like I said, 15 here in Nashua, spent some time at the New York City Forecast Office, Charleston, West Virginia, and Burlington, Vermont prior to that. So not a lot of travels, but certainly some varied experiences, and a native upstater enjoying every minute of my Buffalo Bills having a good season. And hopefully you won't hold that against me too much, but we'll have a good time talking about aviation weather tonight, and feel free to ask questions. We'll try to clarify some things and give you a little better feeling for how our forecasts fit in with keeping the metal moving, as Joe put it.
All right, thanks a lot, Scott. So we're going to start off. We're going to talk about the roles of kind of three different tiers of offices that support aviation. First would be a weather forecast office like our office in Norton, then Scott's office, which is the CWSU, and then finally the Aviation Weather Center. So I'm going to have Bryce lead off and talk about the weather forecast office. Scott is going to talk about the CWSU, and then I'll wrap it up talking about the Aviation Weather Center. So Bryce, I will hand it off to you.
All right, thank you, Joe. And as he said, I will start the webinar tonight by talking about our office here in Norton and what we specifically do for the aviation community and what we can offer both on our website and in any other way that people like to reach us. So if you have taken some of these webinars with us before, you've probably got a good idea of what kind of services that we offer, which are very wide ranging. But here I just wanted to focus on the aviation specific forecast services that we focus on. And so certainly the most important aviation aspect of the aviation program here at the Weather Service or Weather Forecast Office in Norton is our TAF program. And TAF stands for Terminal Aerodrome Forecast. Basically, this is just a forecast, an example of what you see right there in the middle of the screen with all the text. It might, if you're not familiar, if you're not a pilot familiar with reading these, it might look like just a bunch of gibberish. But if you do a little research into how to read these, it's really not that confusing. It's basically broken down the next 24 to 30 hours, breaking down the major the major weather changes, whether it be wind, visibility, the actual weather, rain or snow and whatnot, the ceiling, which is just the lowest cloud deck that we have, and also something called low level wind shear, which is wind shear is basically just when you have a change in speed or direction of the wind with height. So as you go up in the atmosphere, if it's out of the south, 10 knots at the surface, and you go up to 2,000 feet and it's out of the north at 70 knots. That would be a lot of wind shear. So we forecast these things and put them in these lines, and basically each line is a different time. And so we're starting from the top and reading down the list and saying, okay, from say noon to 4 p.m. it's going to be the wind out of the south at 6 knots. And there's cloud, and there's a 2,000-foot cloud deck. And then by the time we get to 6 p.m. tonight, the clouds are going to move out. It's going to be clear, that kind of thing. So we do these for several different locations, including Boston, Bedford, Providence, Hartford, Westfield, Worcester, Hyannis, Falmouth, and Nantucket. And I believe we have a map next showing our TAF sites in relation to, yes, all of the the airports around southern New England. And so you see we have many different airports that really 20 different sites, but we only do TAFs, specific TAF forecasts for 9 of them. I believe that's based on the usage that they get, and Joe or Scott can correct me later if that's wrong. But these are our busiest airports, and so they have their own forecast. Now, something that if you're just a hobbyist or a general aviation pilot, you can get a lot of information, even if there's not a TAF site for your specific airport or location. So I'm going to show you a couple of spots on our website that you can get some good information. So if you go to our website, it's weather.gov/Boston, and the first thing I want to show you is the map, the graphical forecast. So you're going to click on the forecast tab at the top, and it's going to bring up a drop-down menu, and you're going to choose map view, and that's going to bring up this window. And what you're going to be focusing on is where it says the surface visibility and the ceiling height down shown with the red box at the bottom left. And this will let you step by in 12-hour increments or less, and get a good idea of what the visibility is going to do and what the ceiling heights are going to do. Now, you also have an option to get a text forecast, as you see there, and an hourly forecast. So this is just one option that you have here. The next option is going to be an hour-by-hour look via a graph that you see on the right. So what you're going to do, this is our main page on the left. You can either click on the map, on the point and click map we call it, or type your location into the box on the left, and that's going to bring up your what we call point and click forecast. And then when you're on that page, you'll see this hourly weather forecast graphic on the bottom right, and you're going to click that, and it'll bring up a page like this. And this is really customizable, really nice, because you can choose. See on the right, you can choose to show whatever you want, but on the right you have your aviation parameters, so you can check the ceiling height and the visibility. You choose from the drop-down menu what time period that you want it to start at, and hit submit, and it will bring up this nice handy hour-by-hour forecast of everything that you could possibly want to know with regards to the weather. So there's whether you want it to be a text or on a map or on a graph, there's all sorts of ways you can get our forecast for your aviation needs. One last website that I want to talk about before I hand it over to Scott is the CWSU's page itself. So this is going to be our the most aviation information available is going to be on our homepage. You start on our homepage and click the forecast, or hover over the forecast tab, and it'll bring this drop-down menu, and just choose aviation. That will take you directly to the CWSU's page, which I don't believe you have a picture of, but that is a good segue to our next section, which I will pass it over to Scott, because he's going to elaborate on the Center Weather Service Unit and their partnership with us, how they interface with us, and also how they interface with other government agencies in aviation. So Scott, I'll hand it over to you.
All right, thanks, Bryce. So Center Weather Service units, they are located within the air route traffic control centers across the country. There's 21 of them, 20 on the continental U.S. or CONUS, plus Alaska Center up in Anchorage. We are embedded within the FAA units, and we've been in the FAA centers since the late 1970s. And when it says we provide direct weather support to the FAA personnel, that's exactly what it is. The benefit to this job over, say, what Joe and Bryce do at the forecast offices, we get to see most of our customers face to face. We do deal with some other facilities that obviously are over phone, but our primary customers, if you will, are the FAA supervisors at Boston Center. So we can go to the next slide. So we're staffed by 4 meteorologists. We're all NWS employees. We provide weather support 16 hours a day to Boston Center. Boston Center is a pretty good size airspace. Think of an area roughly bounded by Syracuse, New York to the west, Islip, New York to the south, and then we go all the way up to the Canadian border, up to the Crown of Maine. We are not the busiest center in the country. In fact, far from it. We're one of the least busy, but we have some of the most challenging weather. And that's one of the unique things about working in a CWSU. Every center is different. We have all kinds of different flight operations that we deal with, even though our numbers are lower than everybody else's. And we also have that little chunk of real estate called New York City just to our south. And we'll talk about that more in a minute. In addition to the center and working with our partners there, we're also working with the people up in Merrimack, New Hampshire at the Terminal Radar Approach Control, or TRACON. Now, Boston TRACON handles all of the arrival and departure traffic in and around Logan Airport in Boston. Think of a chunk of airspace that goes out about 50 nautical miles from Boston in all directions and goes up to approximately 12,000 feet or so. So the controllers at the TRACON handle all of the traffic inside of that area, except for immediately around Boston Logan Airport or any of the other smaller airports in their airspace. At Logan, they handle the aircraft arriving and departing, immediately arriving and departing the airport. They're only controlling traffic about 5 miles away from the airport and up to about 5,000 feet, and then they would hand it off or receive the handoff from the TRACON. I've given the web page there, and maybe at the end, if we have a couple of minutes, we can do a quick show and tell on our web page. It's not nearly as fancy as the Norton page, but it does provide some pretty decent overview weather. Our big thing in the summertime are thunderstorms. One ill-placed thunderstorm can screw up the entire country. We always talk about New York Center because you have 3 airports crammed into a piece of airspace that normally would just be 1 airport. Well, New York has more than 3. It's actually 4, really. It's Kennedy, LaGuardia, Newark, and Teterboro, New Jersey. And then there are some smaller airports right on the periphery of that area, but those are really the 4 airports. And because they are so close together, they have immense impacts on each other. While my group doesn't deal with them directly, we do indirectly, because anything that affects New York ultimately affects the operation at Boston Center. Next slide, please. So we have a team of 4 meteorologists. Faces have been hidden to protect the innocent or the guilty, depending on how you want to put it. And Joe, in the upper right corner there, from the Boston Norton office, is actually cross-trained to come up, I should say, because we are north of them, to come up and help us out when we get into a staffing pinch. And a number of years ago, we actually had Joe up quite a bit when we were down a couple of meteorologists due to retirements. We're a pretty experienced crew. Between the 4 of us, we're about 115 years of experience in the agency and almost 60 years in the building itself. So, you know, we're not a bunch of rookies. We've got a pretty good idea of what's going on and how things work as far as the airspace is concerned. Next slide. We are not, if you've ever been to a weather forecast office, I can tell you that we are completely different as far as the setup. The picture that you see here, that's about 70% of our operations area. It's a very small area. There's only 1 meteorologist working at a time, especially in these COVID days. You notice all the computer screens. We have multiple systems that we use. Some are weather service systems, some are FAA systems. We have internet PCs. We have systems from MIT Lincoln Labs. We use every piece of equipment, every piece of information we can to help put the puzzle together, because unlike most of the forecasts at Norton and at the other forecast offices, we're not just dealing with what's going on at the surface. In fact, most of the time outside of the TAFs that Bryce referred to, most of the time we're not dealing with the surface. We're dealing with everything above the ground, especially from about 10,000 feet up to, say, 40,000 feet. And yes, the CWSU runs on Duncan. You know, that is an important tool of the trade for us. We are a 16-hour-a-day operation, and Some days are busier than others, so every little bit helps. Next slide, please. So like I said, we are 16 hours a day. We are not actually a 24/7 operation. The ARTCC is. The CWSU, we're open from 6 a.m. to 10 p.m., but the ARTCC is a 24-hour operation. Our airspace is divided into 5 operational areas, and then each area is divided into 6 sectors. Some of them are high altitude, some of them are low altitude. Some of those low altitude airspaces go all the way down to the ground level. Some of them only go down to 10 or 12,000 feet. It depends on what the underlying facilities are underneath. And this is part of the challenge that we have, because the forecast offices, they have set geographical boundaries. Our boundaries are set, but they're not straight up. They sometimes overlap each other. For instance, you notice that we have high level coverage across most of Long Island. Right there in the middle of Long Island is where New York Center is located. We actually have the high altitude airspace over New York Center, but they have the airspace from about 12,000 feet down to the surface. Next slide, please. One of the big thing that we do, and you can describe it in a number of different ways, decision support services is what the Weather Service is all about these days. The CWSUs have been doing DSS since day one. And in-flight DSS is an incredibly important part of our job, even though it may not happen very often. We get what's called a flight assist. We probably average 1 or 2 a month. You're going to get a pilot. He might be a VFR pilot trapped above the clouds. Well, the conditions are VFR. Yeah, well, not to the pilot who doesn't quite know where he is because he can't see the ground. He may have lost his de-icing equipment. That's a huge problem, especially in the wintertime. If you don't have de-icing equipment and you have a system similar to the one that's departing New England now, that's a big problem. Thunderstorms could be, again, we talk about thunderstorms being in a bad location. Well, any location is a bad location if it's between where you are and where you want to go. And there are other in-flight emergencies that crop up as well. So what we do is we will go and talk to the controllers directly, either by phone or in non-COVID days, we will go and talk to them directly. We do not talk to the pilots directly. We feed the information direct to the controllers. They feed the information to the pilots, and then the pilots and the controllers can make their decisions from there. We pride ourselves on being able to provide whatever information they need in a heartbeat. And every flight assist that we've done, at least in the 15 years that I've been at the center, has had what we call a successful ending. They have gotten to the ground safely wherever they needed to be, and it's just part of the job. That's what we do, and we take an immense amount of pride in being able to do that as well as we do. Next slide. So Logan Airport in Boston is our primary airport to deal with. As we talked about, now we are not forecasting for Boston direct, but we are constantly talking with the forecast office to make sure that everybody's on the same page. We provide our input to what we think is going to happen in the forecast. I'll give you a perfect example. I was actually on shift today. Nicole, the forecaster at Norton, calls up and says, this is what I'm thinking. What are you thinking? We discuss it. We're looking at a little bit different information. We come to a consensus on the forecast, and it actually worked out pretty good. Boston cleared out just about when they were supposed to. We were able to give briefings to the traffic management people at the center so that they could pass it on to the areas and to the pilots. What little traffic there was today, everybody was happy. Boston is a tricky airport because if you, and I don't know where our picture went on the slide there, Boston has, there we go. You notice that Boston has a lot of different runways. There's actually 6 different runways there. And you can't just use any old runway anytime you want. It's going to be very dependent on the wind or the ceilings, the visibilities, what type of weather there is. A lesser impact will be what's going on in other locations that may be bringing the traffic to Boston. Something that's a very important thing is what was going on today, and that's snow removal. That we aren't forecasting anything for snow removal other than maybe how much snow they're going to get over a certain amount of time. But the timing on when the heavy bands are going to get to Boston or when the snow is going to start or stop, very critical information. And the better the detail we can give them, the better that they can plan, especially when it comes to snow removal, because on a day like today, they're only running one runway. And when they have to close that runway for snow removal, the airport shuts down for at least a short amount of time. So Boston's a very challenging airport. Some of our other specific concerns that we have, as I mentioned before, traffic in and out of New York. When New York has to change runways, it's not just one runway at one airport, it's all 3 or 4 of the airports at the same time. They basically shut down the New York airspace after everybody lands, turn everybody around, and then start bringing them in on the new runways. We try to help plan ahead for when this is going to happen. So we're not just looking at our airspace, we're looking at others. We're looking sometimes at Chicago, we're looking at the Florida airports. Atlanta's another big one. They are the busiest airport in the country, and we send a fair amount of traffic down to Atlanta. So when Atlanta has problems, whether it's thunderstorms or fog or whatever, that's important information that we have to pass along so that our people at the center who are planning for this can better address whatever issues may come up. Next slide, please. So we have 11 approach controls, TRACONs, in our airspace. We don't deal with anybody except for A90, the Boston TRACON very often, and actually K90 there for the Cape is now part of A90. So that whole airspace is one facility in Merrimack. Outside of those airspaces, we don't really talk to the other TRACONs too much unless there's some type of weather issue, whether it's a line of thunderstorms or a potential flight assist, something along those lines. And then in each of those TRACONs, you have the individual airports. So we're not just dealing with the center or Boston TRACON or Boston Tower. We theoretically are dealing with about 36 different facilities, and we're still not the busiest center as far as the number of facilities. There are other centers that have way more airspace and way more airports than we do. But there's such a variety in the weather. We always joke that in Area D, which is Maine, Cape, and the Islands, you could have a snowstorm going on in Presque Isle, Caribou area. You could have freezing rain in Holton, Maine. It could be raining along the Maine coast. It could be sunny out over the outer Cape, and it could be completely fogged in Nantucket. And that's just one operational area, or in this case, several different TRACON or tower facilities. So it's a very challenging job, and it's very rarely the same from day to day, unless you're in the summertime when the high pressure sitting over you, nothing's going on. So very challenging and very rewarding as well. Next slide. So very briefly, let's take a look at a trip. Say you are flying from Boston to Chicago. You're not dealing with one forecast or one facility. At the air traffic control tower, pre-flight and takeoff, they're looking at the TAF from the forecast office, in this case, Boston. Well, as far as planning for their route, they're going to, on departure, they're going to be handed off to Boston TRACON. So from roughly 5 to 15,000 feet and 50 miles out, the TRACON will be controlling them. So that's one set of forecasts that we're looking at. Okay, what are the winds? What's the turbulence and the icing looking like between 5 and 15,000 feet? Once they get beyond about 12 to 15,000 feet, they're handed off to one of the en route or air route traffic control center controllers. Now, remember we talked earlier, the center is divided into different areas and different sectors. So on a trip from Boston to Chicago, that particular crew is going to talk to somewhere in the neighborhood of about 20 different controllers between Logan Airport and O'Hare. They're going through the Boston TradeCon, multiple controllers through Boston Center. Then they go through Cleveland Center. They're going to go through several different areas at Cleveland. They're then, in all likelihood, going to go into Chicago Center airspace, who will then hand them off as they begin to descend into O'Hare, into Chicago TradeCon airspace. And then the TradeCon will hand them off to O'Hare, and they land, and everybody gets to where they need to be. So there's a ton of different forecasts that go into this for what seems like a very simple 2-hour, 2.5-hour flight. Next, please. So we're looking at icing, and that's at all levels. Now, most icing is below, say, about 24,000 feet. Once you get, especially in the wintertime, you get above 24,000 feet, it's typically starting to get too cold and not having enough moisture to get much in the way of icing. It can happen, but it doesn't happen too much. Turbulence, of course, is a big thing. You've all heard the stories about severe turbulence and the injuries to members of the flight crew and to passengers. Well, our job is to try to pinpoint the areas where the worst turbulence is going to be and the altitudes that it's going to be at. Therefore, the controllers can try to help the pilots avoid those known areas of issues. Problem with turbulence is you can't see it, but you certainly can feel it. Low-level wind shear kind of falls into that, but that's down at the very lowest levels. We typically think of low-level wind shear between the surface and 2,000 feet. And that could be a result of a very quick change in wind speed, quick changes in wind direction, or a combination of the two. So we try to pinpoint those as best as we can. And the low-level wind shear, we're working with the forecast offices. Precipitation start and end, it's actually important as far as rain showers are concerned for starting and ending times. It may not seem that logical that, oh, okay, it's a little bit of rain, it's no big deal. Well, wet runways actually force the airport to spread out the landing aircraft and the departing aircraft a little bit more. So on a nice sunny day, say there's a sea breeze at Boston, 61 aircraft in theory could land at Boston Logan Airport in 1 hour. The minute you introduce some rain to that, you probably drop that arrival rate down into the 30s. Doesn't sound like a big deal until, say, there's an arrival rate of 36 and you're on aircraft number 37. You're going to have to go into holding at some point and wait for your turn the next hour. Precipitation starting and ending, obviously, we just talked about that. Precipitation type, obviously, like today. Snow is a huge issue because if you get enough of it, they have to treat or plow the runways. Freezing rain, ice is a huge issue. You can only do so much, especially if it's a heavier freezing rain. And sleet is actually a huge problem with aircraft. There are some airlines, if there's sleet in the forecast, they won't fly. I won't name the one airline in particular that does that, but they are very safety conscious when it comes to that. Next slide, please. So icing is pretty much what it sounds like. It's ice that sticks to the outside of the airplane. It's when super cool water droplets hit the airframe. Depending on the type of aircraft, the type of de-icing equipment that they may or may not have on board, will determine, how severe the icing is going to get. A 747 can handle an area of icing much better than a Cessna 172. Cessna doesn't have any de-icing equipment on board, or very, very limited. A 747, unless it's severe icing, can probably handle it. There's different ways that they can get around this too. They can go to different altitudes, they use the de-icing equipment, or in the worst case scenarios, they have to go and land someplace. Next slide, please. Turbulence is there's a couple of different things that lead to turbulence. You've heard of jet streams. There are multiple jet streams. Jet stream is just this intense core of winds, and they move different altitudes, different locations. We talked about turbulence is clear. You can't see it, but you certainly can feel it. There are signs that we look for in our forecast information to where's the most likely areas of the turbulence. And the things that we look for are the rapid changes in wind speed, once you start working your way into or out of the core of the jet stream, as shown in the lower right corner. And also when you have changes in wind direction, if you have a very sharp change in the winds associated with the jet stream, say with an upper level area of low pressure, you get those big changes of wind direction combined with a change in wind speed. That's where you're probably looking for the worst turbulence. The same basic premise works for low level wind shear from the surface to 2,000 feet. Typically what will happen is you'll have a warm front working its way into New England. Basically underneath the warm front, winds very light, say out of the north, but right at and just above where the frontal system is, winds are going to be howling out of the south. Well, it's that big change in wind speed and wind direction that can cause major issues trying to get in and out of airports. And depending on the airport and the circumstances of the jet, that can actually be a big problem. And it could be enough to actually shut an airport down if it was that bad. Next slide, please. And now I'm going to hand it off to Joe, and he's going to talk about kind of a group that handles the bigger picture even more than what the CWSUs do.
All right, thanks, Scott. So kind of the third tier of aviation weather services is an office out in Kansas City, Missouri, the Aviation Weather Center, which handles aviation concerns kind of on a national level, and they coordinate primarily with the CWSUs for different concerns. So the Aviation Weather Center is one of the what we call the NCEP centers, National Centers for Environmental Prediction. So think along the lines of the National Hurricane Center, the Storm Prediction Center, the Weather Prediction Center. This is along the same tier of offices. And their website, which is seen here, is under aviationweather.gov. And you can find just a wealth of information regarding aviation. So some of the examples of their forecasts, domestically, there are things called SIGMETS, which are aviation warnings. Again, talking about things like icing and turbulence and low flight conditions, IFR conditions, it's called instrument flight rules. AirMets are aviation advisories. There's significant low-level aviation graphics, talking about significant low-level weather. They also do international too, and I'll show a map here at the end. Significant weather at higher altitudes, oceanic SIGMETS. So think about flights that are coming or going from the United States to Europe or to Asia. And then area forecasts for the Caribbean and the Gulf of Mexico, flights that are going Central America, South America, to and from the United States. So this is basically their area of responsibility. Note, first of all, we have the continental United States, which is, I would say, the majority of what they do. They coordinate with the CWSUs primarily for the concerns that Scott talked about, icing, turbulence, and thunderstorms. There's limited contact with us at the Weather Forecast Office. The CWSUs tend to be kind of the go-between for us, but in the off hours, overnight, when the CWSUs are not staffed, occasionally we may deal with the Aviation Weather Center. But Scott, you probably know as better as I do, but I've maybe talked to them a handful of times in my whole weather service career. It's pretty rare. So
yeah, in all the years that I worked at the New York Forecast Office, I don't think I ever talked to AWC. They do primarily talk with the CWSUs.
Right. So a lot of their role is very similar to what Scott's office does, just on this larger scale. Again, mostly the continental United States, but also, as you can see here, these oceanic areas as well, going into Alaska, the Pacific, where these are flights going over to Asia, and then of course in the Atlantic are flights going over to Europe, and in the Gulf of Mexico, the Caribbean, these going into Central America or even South America. So again, largely the same responsibilities that Scott's office has in Nashua, but just kind of on a larger scale. So that's a look at our aviation weather. Let's see, our next question from Jimmy. Is there a government website where you can see all the air traffic in the area? That's another Scott one.
No, not really. Best thing you can do, there are a couple of different websites out there. FlightAware is one of them. There's another one that I'm drawing a blank on right at the moment. no, not Sky Vector. There is another one. There's a couple of them out there. There is a delay in reality versus what you're seeing for any number of obvious or not so obvious reasons, but it'll give you an idea of what's out there. But there is no one government website that has it all. It's probably done that way for security reasons.
Right. Yeah, I think a simple online search, you can find a few options. This one is a Scott question from Beth. How do you interface with the Canadian and Mexican weather agencies for aviation?
Well, if I have to talk to Mexico, we got bigger problems because that means a lot of things are probably down the toilet. We do talk with the Canadians on rare occasions. It's usually when we're doing our thunderstorm forecasts in the spring and the summer. There is a limited amount of collaboration between the Canadian meteorologists and ourselves. There probably should be more. It shouldn't just be some geopolitical line separating the two. But the Canadian Weather Service operates quite a bit differently than the National Weather Service does. So they don't have the staffing that we do. So it does become challenging. But we can pick up the phone and talk to somebody. We probably talk to them a few times a year. There's not usually too many times. Most of the conversation between the American side and the Canadian side is actually on the air traffic side. We're not really involved in that too very much.
Okay. Just a comment from Jonathan. Boston came in with 12.9 officially. So thanks, Jonathan. I hadn't seen that. So I know it was more than 10. From Brian, what goes into forecasting the ceiling? And what impact does wind direction have on ceilings in our area? That's a good question. Scott or Bryce, do you want that one?
Oh, let's let Bryce have at this one.
Okay. I guess I could answer that one.
Sure.
So, wait, the question was what impact or how do you forecast the ceilings? What impacts that, I think? So basically, to figure out the ceilings, we're looking at relative humidity and how saturated the atmosphere is at certain levels. So we can either look at it in looking at what's known as a sounding, where we see basically traces of temperature and dew point as it goes from the surface all the way up into the top of the atmosphere, and where those two say we're dry at the surface, and so those two dew point and temperature are separated. As you go higher and higher, wherever they come together, that means we're saturated, and so you can pretty well guess that that's where the bottom of the cloud's going to start. So the ceiling would be around that level. We also have different ways to look at it. We can look at it on a map and look at, say, relative humidity in the bottom 1,000 feet of the atmosphere, or in the from 1,000 feet up to 5,000 feet in a map view, and see, kind of visualize the lower clouds moving in, say off the ocean, or from, coming in with a cold front or a warm front. So yeah, it's just purely looking at how saturated the atmosphere is, and if it's dry, there's not going to be any clouds, and if we've got a lot of moisture, then we are going to have clouds and usually low ceilings. And now wind direction can certainly have an effect on that. Like, say, for instance, to tonight and into tomorrow, we're going to have clouds. Much of the area is going to be clear, but along the immediate east coast, because of the wind direction out of the northeast, it's going to be picking up moisture off the ocean, and that's going to be giving us some ocean effect clouds. So the wind direction certainly has an effect, not only from the ocean bringing in different moisture from different directions, but also, if the winds are coming out of the southwest ahead of a warm front, that's advecting in more moisture from the south into a drier area and drier region. So that's going to bring more clouds, whereas maybe from the northwest, it's dry and cold. There's not a lot of moisture coming down with those winds, so we're going to have less clouds. So yeah, the winds and the humidity all play together for the cloud forecast.
All right, thanks, Bryce. Let's see, it looks like we're getting over to some of the storm stuff now. From Shelley, she says she noticed over the past few years that in general, the European models tend to be more accurate than the GFS. Why hasn't the GFS been modified to improve its accuracy? I guess I'll take that one, guys, as the science officer.
Yeah.
So Shelley, yeah, I mean, that's a common theme that we hear all the time. And the European model does have a better track record right now than the GFS. There are occasional upgrades that are made to the models. And remember, the models do have they're all really just a bunch of mathematical equations. That's what models are. They make different assumptions for different processes that take place in the atmosphere. The data that goes in is handled differently by the various models. So we don't want the models to be exactly like each other, or we wouldn't have different solutions. So, but that said, the GFS, there is a new version which is going to be implemented in February as of right now. Right now it's kind of running what's called parallel. It's in testing mode. And in fact, if you were watching the models, you know the GFS wasn't showing much of a hit with this storm until almost yesterday or the day before. The parallel or the experimental version that's going to be implemented actually nailed this storm very well. And we're going to have some slides on our event review coming up probably, like I said, early January that will show it. So the models are constantly tweaked and different kind of assumptions are made for each of the models. But it's also a lot of work. They're very, very complex. The European agency, their model does certain assumptions that the American ones don't, and with good reason. Again, you don't want the models to be carbon copies of one another. So we have access to the European, we have access to the GFS. The thinking is the GFS will be making more leaps and bounds over the next few years. It has a different core, it's called now too. That should be much better, which is paralleled after the European. So stay tuned, but I think I do have good hopes for the version that will be implemented hopefully in February if all goes well with the testing. So good questions, Shelley. Hope I didn't ramble on too much. Let's see, any other questions? Okay, here's one for Scott from William. I subscribe to 4Flight or 4W Flight. What group? Oh, this could be Bryce too. What group composes the forecast discussion under the weather tab page? They are great, informative, and insightful. Bryce,
yeah, that's you guys.
Yeah, as I was reading it, I was like, oh, never mind. Bryce, you can take that.
Oh, I'm sorry. Andrew just came in for the shift change.
Oh, no problem.
And
Then I will answer.
not.
No
I'm
problem.
sorry.
It's actually the forecast discussions come from the weather forecast offices. So the aviation section is composed by our office and other offices too. Usually what you see written there is what we have collaborated with our friends up at Nashua most of the time. So the forecast discussions are issued by the forecast office. And from Matt, let's see, does the public have access to your cool presentation slides? Is there a website? We have them available on YouTube, Matt. So if you go to our YouTube channel, you can watch the presentations there. We don't post the presentations other than that right now, but we could consider, maybe having a website where we kind of have a library of the presentation. So it's all public domain. We're not hiding anything. So that looks like the last of our questions. So I want to thank Bryce, who's now on shift change, and especially Scott Reynolds for joining us. Scott, thank you so much for helping put this together and really giving us a good sense. I don't think a lot of people really know, first of all, that you guys exist. And I know from having worked up there, it is definitely one of the most challenging jobs as a meteorologist you can have, because at the weather forecast office where I am 99% of the time, if you're wrong, yeah, you hear about it. You get complaints all the time. But at the center, if you're wrong, they're in your face. And you've hosed up air traffic around the whole area. So fortunately, the times I've worked there, I've done okay. But it's a really interesting job. So thanks so much for taking the time and presenting all that tonight.
Absolutely. Yeah, it's a challenge. It's, I had no idea what to expect when I took this job 15 years ago. And honestly, I'm not sure I really want to do anything else before retirement finally rolls around, although you never know. But yeah, it's rarely the same 2 days in a row. And like Joe said, it's instant feedback. The controllers and the managers and supervisors, they know when you are kind of giving them a line because you really don't know what's happening. They know when you're dead set that this is what's going to happen. And they let you know when you're wrong, but they also let you know when you're right. And that's a really great feeling that it makes the job worthwhile.
All right. Well, thanks again, Scott, and Bryce. Thank you as well.